What's up, guys? This is Mr. Myasis here, and I am going to talk to you about some probability problems and then look at finding the odds of an event. So let's take a look at this guy here, and we'll try to get through as quick as possible. This is just some review information about probability and the success and the failure. So I'm just labeling them as S and F here. Failure is the undesired outcome, and if you add the successes and the failures, it's the total number of possible outcomes, right? So let's go and take a look at some examples, and we're going to talk about what an odds of an event and how is odds different than probability, because you'll see that a lot. Oh, the odds of getting the 6 is this, and so it's a little bit different than probability itself. So you see that a lot in like sports. You know, they say the odds of them winning is 5 and 2. So we'll see what that means. So suppose you select 2 letters at random from the word compute. Find each probability. Okay, so I'm picking 2 letters, and this is not with not with replacement. Okay, so we're talking about dependent events here. Pick 2 vowels. All right. So the probability, and we kind of did this in class the other day. The probability of picking my first vowel is 1, 2, 3. I got 3 vowels out of 1, 2, 3, 4, 5, 6, 7, right? So 3 out of 7. That's the probability I pick 1 vowel. Then I've already picked one, so the probability of picking another vowel would be 2 out of 6. All right, now I simplify that. It goes into twice, 2 and 2, and I get 1/7 as my answer. Well, we're talking here that we don't care what order these are in, that we get these vowels. And if this was a more complicated problem, we wouldn't be able to do this easy dependent probability that we did. What we would need to do is we would need to take the total number of ways of getting 2 vowels, right? So like O, U, and O, E, and O, I'm sorry. Okay, hold on. So O, U, and U, O, U, O, those are the same thing, right? And EO, these are all the same. So I got repeats, right? So I'm going to have OU, OE, EU, and is that it? OU, OE, EU, and UE. No, U. Yeah, I think that's it. Okay. So what we would do is we would try to find all of the possible combinations to get 2 vowels, and divide it by all the combinations of getting 2 numbers given 7 letters. So what that looks like is the 3 combination 2. So 3 choose 2 over 7 combination 2. All right, so this is how we do it with combinations. We're going to say I have 3 vowels, 1, 2, 3. 3, choose 2 of them. Choose 2 of them. Divided by 7 letters, and I'm going to choose 2 of those. And then if I do this in the calculator, I'll just show you real quick in the calculator. So I'm in my TI Inspire here, and I get N 3 choose 2 divided by 7 choose 2, and I get 1/7. 1/7. That's what I got right here. Okay, so it comes out to be the same thing. So if we have a problem where we can use combinations as their probability, that's this is how we do it. I prefer this method here. We see this a lot more in AP Stats, but sometimes we have a probability problem that's a little bit too complicated with dependent probabilities in order to do it. Again, this really only happens if we're dealing with dependent. If we have an issue where the probability stays the same, then we have a totally different type of probability that we can do, which you'll get to in AP Stats or another class. So let's take a look at some examples of using this same idea, using these combinations. And guys, I'm just going to give you this part, and then I'm going to plug it in the calculator, and just so hopefully you know how to plug this in the calculator. So if not, we'll go over it tomorrow in class, but we've done that And I just showed you on the TI Inspire. So let's take a look at another one. How about two consonants? Well, we're going to, how many consonants do we have? 1, 2, 3, 4. So I'm going to do 4, and I'm going to choose 2 of them. Divided by, I have 7 letters, and I'm going to choose 2 of them. All right, so this is my probability, and that's going to give me 2/7. That's it. That's all you got to do. So you think about how many of my consonants I want to choose out of choose 4, choose 2. So think of this as choose. All right, let's take a look at another one. 1 vowel and 1 consonant. So remember when we talked about we have 2 probabilities. This little parentheses means and. So when we have and means multiply. So what I'm going to do is I'm going to take this combination and I'm going to multiply it by this combination. All right, so it looks like this. I have 1 vowel that I'm choosing out of 1, 2, 3 vowels. So 3, and I'm going to choose 1. And I'm going to multiply that by 1, 2, 3, 4 consonants, and I'm going to choose 1 of those. Divided by 7, choose 2 letters. All right, because I have 1, 2 letters that I'm choosing. All right, and then that's going to be my answer for this, and that's going to be 4/7. Okay, so if we had 2 different things, events going on in this case, we would want to multiply the top. The bottom's going to stay the same because I'm still picking 2 letters. Let's take a look at another one. Roman has collected, Roman, that's my dad's name, has collected 13 books. 6 are fiction, 7 are nonfiction. He randomly chooses 8 books to take on vacation. All right, he wants 4 fiction and 4 nonfiction. So let's do the 4 fiction. 4 fiction is, so how many fiction do I have? I have 6. So I'm going to 6, and I'm going to choose 4 of them. How many nonfiction? 7. So I have 7, and I'm going to choose 4 of them. Divided by the total number of things that I'm taking. I have 13 books, and I'm going to choose 8 of them. All right, I'm going to plug that into my calculator, and I'm going to get 175 over 429. Okay? And if you don't have a calculator, if you're another student, you don't have a calculator that you can easily do this in a graphing one, you might have to use the formula. All right, let's take a look at another one. Roman has a collection of 13 books, the same situation. How about 3 fiction, 5 nonfiction? So I have 6, and I'm going to choose 3 times, you like the way my voice went up there? 7, choose 5, and then I'm going to have 13, and I'm going to choose 8. Okay, this is the total of them I'm taking. All right, put that in the calculator. Bada bing, bada boom, bam, 140 over 429. That's it. That's all there is to it. Okay, just remember how to do those things. Okay, so then let's go on to odds. All right, the odds is the ratio of the number of successes to the number of failures. All right, not bad. S ratio F. Let's take a look. Find the odds of an event occurring given that the probability is 2/9. Well, remember that the probability is S over S plus F. Okay, this was this is what I had in the beginning of the video. Let's go right back. Here we go. Okay, S over S plus F. Okay, so if I'm doing this problem here, and I know that S has got to be 2, right? That's the probability. So I know S is 2. What's F? F has got to be 7, right? Because 7 plus 2 is 9. F has got to be 7. So what's the ratio? S to F? It'll be 2 to 7. That's it. Yeah. Really, right? That was all you got to do. Okay, what about to find the probability of an event occurring if the odds is 7 to 5? Okay, remember that this first number is S, this second number is F. Okay, this is the number of successes, this is the number of failures. My probability, I'll use a different color here, my probability was equal to S over S plus F. So let's just plug it in. S is 7. 7 plus 5 is 7 over 12. That's it. God, can you believe how easy that was? All right, boom, later, done.